Hello, welcome to Optical Fiber Communication lecture series. Today we will discuss lecture 3 about evaluation of fiber optic system. Request to like, share, comment, subscribe and do not forget to press bell icon to receive latest video from this channel. John Tyndall demonstrated in 1870 that light can be bent. This can be considered the first demo of guided light propagation. Total internal reflection is the basic idea of fiber optic. In this figure, light is emitted from sun to the basin of water. And we can see the water flow out of the basin with light reflected from source and light gradually leaks out. First, developed in 1970s, fiber optic have a revolution as that telecommunication industry have played a major role in the advent of information age. Because of its advantage over electrical transmission, optical fiber have largely replaced copper wire communication in core network in the developed world. In 1880, Alexander Graham Bell and his assistant Charles Savarin created a very early precursor to fiber optic communication. The photophone at Bell's newly established Volta Laboratory in Washington, D.C. Bell considered it his most important invention. The device allowed the transmissions of sound on a beam light, and on around 1818, Bell conducted the world's first wireless telephone transmission between two buildings around 200 meters. Due to its use of an atmospheric transmission medium, the photophone would not prove practical until advances in laser and optical fiber technology permitted the secure transmission of light. The photophone's first practical use came in military communication system many decades later. In 1954, Harlow Hopkins and Narendra Singh Company showed that rolled fiberglass allowed light to be transmitted. Initially, it was considered that the light can transfer only straight medium. Junichi Nashinga, a Japanese scientist at Tokugawa University, proposed the use of optical fiber communication in 1963. And it is invented the pin diode and the static inductor transmitter, both of which contributed the development of optical fiber communication. In 1966, Charles K. Cow and George Hockman at STS Laboratory showed that the losses of 1000 dB per kilometer in existing glass compared to 5 dB per kilometer in coaxial cable were due to contaminants which could potentially be removed. Fiber was successfully developed around 1970 by Corning Glass Works with attenuation low enough for communication purpose about 20 dB per kilometer, and at the same time gallium arsenide semiconductor lasers were developed that were compact and therefore suitable for transmitting light through fiber optic cables for long distance. In 1973, Optical co-founded by the inventor of the laser, Gordon Cole, received a contract from the first optical fiber communication system. Developed for Army Missile Command in Huntsville, Alaska, it was laser on the ground and a spout of optical fiber played out by missile to transmit a modulated signal over a 5 kilometer. After a period of research starting from 1975, the first commercial fiber optic communication system was developed which operated at around wavelength 0.8 micrometer and used gallium arsenide semiconductor laser. That is nothing but the first generation fiber optic system. The first generation fiber optic system operated at a bit rate of 45 megabit per second with repeater spacing up to 10 kilometer. It used technology of 0.8 micrometer gallium arsenide semiconductor laser and multimode silica fiber. Its limitation is fiber attenuation and intermodal dispersion. That is deployed since around 1974. They moved to the second generation system that bitrate operated around 100 megabit per second with repeater spacing up to 50 kilometer, element repeater in long distance line. The development of low attenuation fiber is the purpose to removal of S2 and other impurities. It uses 1.3 micrometer multimode semiconductor laser, single mode low attenuation silica fiber. Its limitation is fiber attenuation, which require repeater spacing around 6 km. This kind of system is developed under around 1978. Then third generation system that operated a bit rate of around 10 GB per second with repeater spacing up to 100 km. Deregulation of long distance market is the purpose, and technology is around 1.55 micrometer single mode semiconductor laser with a single mode low attenuation silica fiber. Its limitation is fiber attenuation that requires repeater spacing around 40 km with fiber dispersion, and that deploys is around 90 MP2. Then move to the fourth generation fiber optic system. The fourth generation fiber optic communication system use optical amplification to reduce the need of repeater and wavelength division multiplexing to increase data capacity. These two improvements cause a revolution that result in the doubling of system capacity every 6 months starting in 1992 until a bit rate of 10 TB per second was reached by 2001. In 2006, a bit rate of 14 terabyte bit per second was reached over a single 160 km line using an optical amplifier. The focus of development for the fifth generation of fiber optic communication is on extending the wavelength range over which wavelength division multiplication system can operate. The figure of optical fiber attenuation is a function of wavelength. One of the principal characteristics of an optical fiber is its attenuation as a function of wavelength, as shown in figure. Early technology made exclusive use of around 800 to 900 nanometer wavelength band. In this region, the fiber made at that time exhibited a local minimum in the attenuation curve, and the optical source and photodetector operation at this wavelength were available. This region referred as a first window. By reducing the concentration of hydroxyl ion and metallic impurity in the fiber material, around 1980s, manufacturers were able to fabricate optical fiber with very low loss in 1100 to 1600 nanometer region. This spectral band is referred to as a long wavelength region. Two windows are defined here. The second window centered around 1310 nanometer and the third window centered around 1550 nanometer. Internet protocol data traffic was increased exponentially at a faster rate than the integrated circuit complexity had increased the under Moore's law and from the burst of the dot-com bubble through 2006. However, the main trend in the industry has been consolidation of the firms and offering of manufacturing to reduce cost. Companies such have taken advantage of fiber communication to deliver a variety of high throughput data and broadband service to consumer homes. These are the reference and request to like, share, comment, subscribe and press bell icon to receive latest video information from this channel. Thank you.